Welcome everyone, my name is Christian Wilms and I'm going to introduce you to our ECCV 2024 paper on SOS segment object system. SOS addresses the task of open world instance segmentation, therefore I will briefly introduce you to this task. So in traditional instance segmentation, the task is to segment all objects in a closed world. So we know during training all object classes, and this is different in open world instance segmentation. In open world instance segmentation, we have during training a set of seen object classes which are annotated in the training data. For instance, here in this example, the person. While during testing, we have a set of unseen object classes which we are actually looking for. So in this case, the surfboat. So the surfboat is not annotated in training, but we expect our system to find these objects during testing. This explicitly challenges the generalization ability of systems. Since we have a segmentation task, you may argue why not just using a segment anything model with a grid of point prompts, so in the everything mode. For this input image, you would then generate something like this as a result. So on the left, you can see the grid of point prompts, and on the right, you can see all the segments that SAM generates, and you can easily see that there are tons of segments on background regions which are not relevant for open world instance segmentation tasks. So SAM is just not focused on objects, but segments anything in the image. Our idea is now to focus SAM on objects by providing object-focused prompts and then utilize the resulting segments as pseudo annotations, additional pseudo annotations for the training data set. So let me introduce you to our segment object system, which starts from the input image. And first, we generate a so-called object prior to roughly localize the objects in the image. To generate an object prior, we have evaluated various different methods in our paper and found out that self-attention maps from self-supervised Dino work best here to capture pixels which are potentially part of an object. So this is encoded here as a heat map with red values indicating high likelihood for an object. So from this object prior, we randomly sample locations given these probabilities and end up with a set of point prompts. And then we apply SAM with the input image and each point prompt individually to generate a set of segments, which is then focused on objects or object parts. After some post-processing, we generate a set of pseudo annotations out of that and merge these annotations with the original annotations. So as you can see in the top right, the final annotations not only cover the original annotations, so the two people in here in the image, but also, for instance, the elephant. And then we use this final annotation to train an instance segmentation system like maskr-CNN on the mixture of annotations. And maskr-CNN here is the only part which is trained, so both Dino and SAM are not trained and just pre-trained. Let me show the results of SOS on the cross-category open world instance segmentation setup on the COCO dataset. So we train on VOC classes, 20 VOC classes, and evaluate on the other 60 classes annotated in the COCO dataset. We measure the results with average precision and recall as other systems do as well, and also report the harmonic mean F1 score. So SAM as a baseline generates very strong recall, so finds several unseen objects, but the precision is quite low, which is expected as several background segments are also part of the result. Recent open world instance segmentation system, on the other hand, have a slightly higher precision, so they are more focused on objects, but they have a much lower recall because they are unable to segment that many unseen objects. So finally, our system has a quite decent recall, slightly lower than SAM, but much higher than recent open world instance segmentation systems. And we also have a much higher precision due to these object-focused prompts, also much higher than vanilla SAM. And this leads to the best F1 score among all the methods. If you want to see more results, also qualitative ones, check out our paper and also check out our code if you want to run this on your own data set. Just feel free to scan the coarcute for that. As to conclude this talk, we have a couple of take-home messages for you. So first of all, we transformed SAM into an object-focused segmentation system without any training. So not just segmenting anything. And second, our SOS substantially improves the precision in open world instance segmentation tasks. So thank you for your attention.